Hi everyone, welcome to the PalmTech tutorials. In this tutorial, I would like to explain about the recursive functions. We will see how we can write a recursive function to calculate the factorial of a given number. So let us understand what is a factorial and what is a recursive functions, and we'll also see how we can write a C# program to calculate the factorial without recursive method and with recursive method. So in the next video, I would like to explain a real-time example to show the recursion. So please refer the recursion real-time example video from PalmTech tutorials to get a clear clarity about a real-time scenario to show the recursion here, right? Let's understand what is a factorial. The factorial of a number is the product of all the integer number from 1 to n. For example, if we want to calculate the factorial value of 5, we just want to multiply the integer value from 1, 2, 3, 4 and 5, and we will get the factorial here. Or you can multiply from 5 to 1, and which also give the same factorial value here. Okay, let's understand what is a recursive function. A recursive function is a function that calls itself during its execution. This enables the function to repeat itself several times. So below snippet, if you see, the calculate factorial is the method name which will take an integer value as a parameter, and inside the method we are making the call to the same method calculate factorial. So such kind of methods are called recursive method because it's getting called in from the same method here. So this approach, when we write a method in such a manner, it is called a recursive method. Okay, let's see the factorial, or let's calculate the factorial of a number without recursion, right, using a C# program, and then later we will see how we can write the same thing to calculate the factorial with recursion. So first I'm going to get the user input for the number, like enter the limit of the factorial from a console window, and then I'll read the value from the console, which always will be a string value. I'm going to convert that and storing into a variable called n here. I declare a local variable factorial and initialized with 1, and I have a simple for loop which start from n, I is equal to n, I greater than 0, I minus minus, and the factorial is equal to factorial into I. So basically I multiply the value factorial using the I here, right? Finally I'll get the factorial in this local variable, and I'll again display the same value to the console window here. The one thing which we need to note here, the initialization of the variable is 1. If you initialize it with 0, the final output is going to be 0 because we have a multiplication here, right? This is a simple program to demonstrate the calculation of a factorial without recursion. Let's see how we can implement the same thing with a recursion. So in the recursive method, in this particular method, I'm just getting the user input as discussed previously, and I declare a factorial variable here and passing a method called calculate factorial, and the integer value is passing to the calculate factorial method. Once this method is getting executed, I will get the factorial value here, and then the same value I will output to the console window, so that we could see the factorial of n by recursion is so and so. In this method, the calculate factorial method, which receive an input parameter as an integer value, right, and then it calls the same method again. The calculate factorial is called from the same method, and which basically pass an n minus 1 here. So since the n is getting decreased every iteration, we know that it will reach a condition n is equal to 0, and when n is equal to 0, right, it goes to the else case and it returns the value 1 here. So this is a simple recursive method to calculate the factorial of a number. Now the important things here, when you write a recursive function, it should always have an exit condition, the proper exit condition. If we don't have a proper exit condition, there is a chance that the recursive method can go to an infinite loop here, right? So that is a very important when we write a recursive method here. Okay, let's see how this is going to work in the Visual Studio, right? Let me open a Visual Studio prompt here. So to make it faster, I already created a console application here called recursive functions, and I've wrote the snippet here in the programs program.cs. The static void in the startup of this project, right? As we discussed previously, I'm getting the user input here, enter the limit of the factorial, and the value is getting read using the read line, and then converting and saving into a variable called end here. So in this place, I'm going to show the calculate factorial with a simple for loop. I created a small method here and passing the input value here, right? And when after this execution of this method, the factorial value will be saved in this fact1 variable, and I will output that variable to the command prompt, the command window. The factorial of the given number without recursion is that value, right? So, and I'm going to write again to show how the value will be displayed when we use the recursive methods. So I have another method called factorial via recursion, and I'm passing the same input value to this method, and the output will be saved into the fact2. I can use the same variable fact1, which will get reinitialized here, but to avoid the confusion, I have declared another variable here. And the same way, I'm going to write the output to the console window. The factorial of n with recursion is fact2. Okay, let's go to the factorial with the loop, for loop, right? So if you see this method here, this is what we discussed previously. The factorial is initialized with 1, and here I'm running from I is equal to 1, I less than or equal to n, I plus plus. In the demo I was showing I is equal to n and at greater than 0, but we can run it from the 1 also. The one point we need to note here, I initialized with 1 and I'm going to check with less than or equal to. If I initialize with 0, the final value is going to be 0 here, right? So, and here also I initialize with 1 here. These are the small things which you need to see in the factorial calculation. So this is a simple for loop to calculate the factorial. And let's see how we can calculate the factorial using a recursive method. The method is here. So if you see, this same method is getting called inside, and I have the condition n greater than 0. Till n became 0, it will go on reduce the value of n here and it calculate it repeatedly. So now I'll go and run this application. So basically you will see the value from recursion and without recursion. Let's run this. Okay, enter the limit of the factorial. Let me enter 5. Okay, you can see the factorial of n 5 without recursion is 120 and with recursion is 120. So both the values are coming same value. Okay, so the method is working perfectly. Now I just want to explain one more thing over here. If you see both the methods, the factorial with for loop and with recursion, so we can achieve this functionality by having a simple for loop. Then what is the real use of a recursive method which can go for infinite loop if we didn't handle the X condition properly? So if you see this factorial calculation, probably the recursive method is not really required over here. But there are scenarios in the real world we could use the recursive method, or probably it will never be, or it will be very difficult to solve using a for loop or some other way, and the recursive method can solve that kind of issue, the real-time issues, with a couple of lines of code. So I have I would like to explain a real-time scenario. It's a small demonstration or the small real-time scenario, and how we can solve the real-time scenario with a recursive method in my next video, which is, you can search it like real-time recursive method example, the real-time example for recursive method, and the another video. So thank you for watching.